All right. So we're looking at section 6.4, solving polynomial equations, and I want you to understand that we're going to skip examples 1 and 2. Might talk about those in class, but we're not going to take notes over those two examples. We're going to go right to example 3. In example 3, we're talking about factoring, and this is called a difference or sum of squares. In this example that I've shown you right here, this is a sum of sum of cubes. I keep saying squares, but I should be saying cubes. So you've got two perfect cubes and they're being added together. Now, in the example we're going to do here in a minute, we're going to do a difference. But the same exact rules apply. You're going to take a cube root and a cube root. You're going to basically we're going to break this thing apart into two things, a linear factor and a non-factorable quadratic. So you're going to split it up into two things, one that has two terms and one that has three terms. And the first thing you do is take a cube root for both of the linear terms. And it's the exact same sign carried down in between. The next thing you do is you want to take this value right here, whatever it is, whatever term that is, and you want to square it to get this one. Same thing for this last one. Take that one and square it to get this one. The term here in the middle that's found is by taking these two terms and multiplying them together and putting the opposite sign with it. So we had cube root, same sign. Square it, multiply them together with the opposite sign. So let's see if we can apply this logic. We take the cube root and the cube root. If you don't know your cube root of 8, it's 2. And the exact same sign in between. Square it, multiply these two things together, which would be negative 2x, and take the opposite sign, which would be positive 2x. There we go. We broke it apart into two things, a linear factor and a non-factorable quadratic. You cannot break that down any farther. You are done. In example 4, they say solve this. Find all the complex roots. Well, what they're trying to do is they're trying to get you to factor. Some kids like to subtract 1, divide by 27, take a cube root. In doing that, you're only going to find one solution, and we need 3 solutions. I know that it needs 3 solutions because I'm looking right there at the degree. So let's see if we can factor this using the ideas we just talked about. So we need cube root and cube root. Well, the cube root of 27x cubed is 3x. And the cube root of 1 is 1. And we need the exact same sign in between. So we did cube root, same sign. Square it. Yeah, some of you wanted to say 3x squared, I know. Square it. Multiply these two together and take the opposite sign. At this point, it's easy to solve the one on the left, right? The one on the left's the easy part, right? Set each one of the factors equal to 0 and solve them. Right? So this one's easy. 3x, subtract a 1, divide by 3, so negative 1/3. Well, that's one of the 3 solutions. How do you find the solution to this? Well, several of you might remember the good old quadratic formula. X equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So that's 3 over 18 plus or minus the square root of something over 18. Let's see here. What's my discriminant? 9 minus 36. That's negative 27. Square root of negative 27. What do we got there? That can be split apart into the square root of negative 9 and the square root of 3. So we have 3 over 18. That reduces to 1/6. And then this is 3i, radical 3 over 18. That 3 right there on the outside is going to reduce with that 18, giving me 1/6 6 plus or minus I radical 3. So those are my other two solutions right there. So I've got that solution over here, which is a real solution, and these two imaginary solutions, or complex ones. So we found all the solutions. So you're going to have to use the quadratic formula. That's for sure. Example 5. This is a little bit different. If you know how to factor this, right? X, and one's a plus and one's a minus, and factors of 8 whose difference is 2. So I'd have a 4 there and a 2 there. If you know how to factor that, then you'll do fine with the next part, right? Okay, because all you need to do is do the same type of thing here, except instead of x, we have x squared. I know that's a little bit different. All right, one's a 4, one's a 2, that kind of thing, just like we had a few seconds ago. Now, keep this in mind. If you have any terms that could be factored farther, you must factor them farther. So for instance, this gets broken apart, right? You can break that apart into x plus 2 and x minus 2. This one, however, is not something that can factor, so we are finished. Which leads me to the next example, which is very similar, that you're solving an equation. The first thing I would need to do is subtract 12, and oh look, it's another factoring situation, just like we had a few seconds ago. X squared and x squared, one's a plus, one's a minus, because there's no way to get negative 12 as a product if you don't have a plus and a minus. Factors of 12 whose difference is 1, that would have to be 4 and 3. Well, guess what? Set one each. Now you can either factor this farther, right? X plus 2, x minus 2. That's probably the best idea. Get it factored as far as you can possibly factor it. Oops, got to show you. And then once you get it factored as far as you can go, then set each one of the factors equal to 0 and solve them. Okay, obviously that one's going to be pretty easy, negative 2. That one's going to be pretty easy, positive 2. X squared equals negative 3. Take the square root of both sides. This sounds like a plus and a minus I square root 3. So we've got 4 solutions. How in the world did we know we were going to come up with 4 solutions? Because we started out with a 4th degree polynomial. Right back here at the beginning, we saw it was a 4th degree polynomial. That kind of clued us in that we'd have 4 solutions. Turns out that 2 of them are real and 2 of them are imaginary. And make sure you're ready for class tomorrow on section 6-4.